Hello, my name is Amber Marsh and I will be presenting the final project for ADTA 5240. For part 1, a strategy to deploy big data technology in a firm. The company I will be talking about is ExxonMobil. ExxonMobil is one of the largest companies in the United States for oil and gas. These are the current issues I have personally experienced through ExxonMobil. Number 1 is outdated technology. Exxon has tremendous amounts of data coming in daily. They're currently using Excel to analyze and calculate natural gas metrics. This can result in long wait times and allows potential keying errors. Number 2 is poor training. Exxon has very little resources on job responsibilities and system guides. Employees rely heavily on help from other coworkers. This results in more time being spent to train employees. Number 3 includes lack of communication. Exxon has a communication gap between many departments. They rely heavily on the IT department to solve their problems. This results in less productivity. The following include the implementations I propose for this company. They include Data Lake, OpenRefine, Hadoop Hive, and Spark. All of these together would increase the value of the company and ensure that we are processing and analyzing data efficiently. For Data Lake, this program has a large storage capacity in one location. It can include structured, semi-structured, and unstructured data. This is very important because ExxonMobil has tons of data coming in almost daily and hourly. This can include upstream, downstream, oil and gas metrics, even revenue and other calculations. The next program includes OpenRefine. This tool cleans data in order to get better analytical results. As stated in the previous slide, Excel is used almost daily to clean data. This could help that problem by having a faster, more efficient way to clean data, which would, as I said earlier, increase productivity. The next one includes Hadoop Hive. This and Spark are very important to the analytical capabilities that Exxon could improve on. For Hadoop Hive, many subsystems work directly with Hadoop to provide a user-friendly experience for data storage, processing, analyzing, and other big data usage. Spark, on the other hand, works very closely with the Hadoop ecosystem. However, it runs on memory, which makes it over 100 times faster at processing data. This could increase the company's value tremendously by processing all the data that has been missed previously. By implementing all of the systems in the previous slide, this will allow ExxonMobil to have a competitive advantage over all the other oil and gas companies in their sector. This new technology will increase analytical capabilities. Training will allow an increase in skills, which will increase productivity and communication. This will allow Exxon to stay ahead of the competition, which will increase the value of the company and maximize growth. Part 2 includes data pre-processing. To clean data, this is very important to get better analytical results. The first step we need to do is clean the CSV data file. The comma being used for a CSV file indicates that it is a separator. We needed to change the commas in the column labeled product name to make sure there are no issues when we do query the data. We can quickly do this by creating a find and replace in Excel. After that is done, another way to clean data is using OpenRefine. OpenRefine is an application that can clean and transform data. Now we are going to look for any errors with the state name or postal code. The first thing we need to do is convert text format to numerical format under the column postal code. We can see when we do filtering that the postal code is in text. There is no numeric value. To change this, we would click this drop-down menu, Edit Cells, common transfers to number. We can now see in the filtering column that numbers, the numerical format has been changed. The next step is to check state names and postal code. We can see when doing a filter on the state names that there are no issues with spelling. On the zip codes, however, we can see that there are a couple zip codes that are 4 digits instead of 5. This is very important to note out because for a postcode to be accurate, it has to be 5 digits long. In order to fix the postal code column, we click the drop-down menu under postal code, edit column, and add column based on this column. Once you do this, this pop-up will appear. We enter this expression to show that if the zip code is less than 5 digits long, 4, before or less, it comes up with the value 99999. So we can see how many are actually 4 digits long. By doing this, we get this result. This is the original postal code column, and this is the zip code column. We can see that there are 449 areas where the digits are 4 or less. To understand what is wrong with the postal code column, we need to verify the zip codes to determine if it's a typing error or another issue we need to fix. To do this, we selected 2 random states and cities and to see what their zip code actually is. By using unitedstateszipcodes.org, we were able to determine the following. For Fairfield, Connecticut, on the postal code in our data, it was 6824. By looking it up, it is 06824, showing us that it is just missing the leading 0. To check another one to be sure, we checked Westfield, New Jersey. On the data set, it is 7090. Right here, by looking it up, it is 07090. So we can conclude that the leading 0 is missing from our data set. So now to correct that zip code error specifically. So to do this, under postal code column, you click the drop-down, Edit Cells, Transform. After that, you include this expression, which basically adds the leading 0 to the zip codes that have 4 or less digits. Part 3, Apache Hadoop Ecosystem with Hive. Regarding the previous section, when we transformed and cleaned the data, we saved that file as a CSV file. In order to do our analysis, we need to upload this file into Google Cloud Platform. In order to do this, you go into your account and go under Storage and Bucket Details. You upload a file, and right here you can see once it's uploaded, it'll say complete. The next thing you need to do is start all your clusters. To verify they have been running and started, they will have these green check marks. The next thing we need to do is create a directory and copy files. With the command hdfs dfs mkdir /user, my username, data /sales records, we can see that this mkdir means that we're creating a directory. It shows that we're creating a directory to include the name sales records. With the next command, hdfs dfs /ls, this ls shows what is in the file or the directory. It verifies that the new file called sales records was uploaded or created successfully. The next thing we need to do is type cd data. This indicates that we are in the data section. Once we do this, we create or add the command line gsutil cp gs and then the rest. you can see that at the end of this, it is sales_record/cleaned.csv file. This indicates that we are copying the CSV file from the GCP bucket to the local storage of the master node. Just like before, when we do the command ls-l, this is to verify or to show us that the file was copied successfully. We can see this because the file is located right here, sales_records_cleaned.csv. The next thing we need to do is to put this file into the correct folder. We do this by using the command hdfs dfs/put. We put the CSV file into this folder path, and at the end, the folder is labeled Sales Records. Again, we use this expression -ls in this new command line to verify that it was copied and put in the correct file successfully. We can see this because it found one item in the folder Sales Records. What they found in the sales record was the CSV file that we uploaded. The next thing we can do is start the Hive interface to be able to query our data. To start Hive, we use the command line beeline-u /hive2:/localhost:10,000. This shows that it's connecting to the Hive interface. You know it's done when it says this. The next thing we need to do is to show the current tables that we have by using the command showTables:. We can see that these tables are already in the Hive database, and it's 4 separate tables. This shows that our data, the sales data we uploaded, we need to create a table in order to use it. In order to do this, we have to do this long command line. It's very easy if you take it step by step. The first step is to create an external table if it doesn't exist. We're going to call this table sales_1. The next we need to do is to explain or show all the different categories or column headers that are used in the data set. This includes row ID, order ID, country, postal code, category, sales, and profit. You can also see next to it these words called string and double. String indicates that the data is going to be transformed into text data. However, down here with double, that shows that it's going to be a numerical value, but in monetary value. So basically, with 2 decimal points behind it. The rest, these are all the same. We make sure that fields are terminated by the colon because it is a CSV file and that's how it's separated. We're going to sort it as a text file, and we're going to upload it to this location. User, my username, data, and then the folder we created called Sales Records. After this, we type the command showTables like we did previously. We can now see that the newly created table, sales_1, was created, and we can move on with the next process. Now we can complete Query A, the top 5 states where the company has the most number of customers. To do this, we are selecting the categories that are needed to solve this analytical problem. First, we need the state. So we select the state, and then we're counting the customer ID as the number of customers. This will count and basically count the number of customers in that state. We verify it's from the table we just created, sales_1. For formatting issues, we're going to group it by state and then order it by the number of customers. But we want the top 5, so we're limiting it by 5. Once you do that, you can see the table that's been created. The top 5 states are California, New York, Texas, Pennsylvania, and Washington. Now we can create query B, the top 10 zip codes areas where the company gets the best sale amounts. Basically, we do the same thing as last time, verifying our categories or columns that we want to determine the analytical results. First, we select the postal code because we're getting the zip codes. We sum the sales, and we're going to title that as total sales. Again, we're using the data with the table we created, sales_1. We then are going to group it by the postal code or zip code, but we want to order it by the total sales. Again, we only want the top 10, so we're limiting it by 10. By doing this, we can see the results of the table showing the top 10 zip codes where the companies get the best sale amounts. Part 4, Apache Hadoop Ecosystem with Spark. Now, instead of Hive, we are going to use Spark. To start the Spark interface, you will use Spark-SQL. This one looks longer when you're starting it. When you are connected to the Metastore and then you have this down here, you know Spark has started. The first thing we're going to do, like we did last time, is show the tables. We can see that the Sales1 table that we created in Hive is here. Now we can do query A. We do the exact same expression as we did in Hive, and we just hit enter. The results are the same, with the top 5 states being California, New York, Texas, Pennsylvania, and Washington. Now we're going to do query B. Again, we're using the exact same expression, but we're doing it in Spark. We get the exact same results with the top 10 zip codes where the company gets the best sale amounts. Part 5, Comparison of Hive and Spark. When comparing Hive and Spark, Spark is typically faster. By looking at query A, we can see that Hive took 29.023 seconds to get this result. But with Spark, it only took 8.765 seconds to get the same results. Now query B. With Hive, it took 17.073 seconds, but with Spark, we can see it only took 9.20 seconds. You can see the dramatic results, how Spark is much faster than Hive. And that's it. Thank you for tuning in.